Welcome back. So today we're going to be working on 8.4 with some proportionality theorems. So you should have a green foldable that looks like this. And we actually have 3 theorems today that deal with triangle proportionality. These are typically theorems that I would use if we don't know that 2 triangles are similar. Okay, so these can help you to be able to prove triangles similar. All right, so we're going to start with the triangle midsegment theorem. So that's this top one. So a midsegment, if you remember, that is the middle. So DE is a midsegment. So it's actually E is in the middle of AC and D is in the middle of AB. So then for this one, it tells us that a midsegment of a triangle is parallel to one side of a triangle. So we need DE to be parallel to BC. And its length is half the length of that side. So our midsegment is DE. It is half the length of the side that it's parallel to, which is BC. Okay, so I'm just going to highlight our parallel sides there. So remember, when we're dealing with midsegment, we're looking at those 2 parallel sides. All right. So we're going to do a couple of examples dealing with this. So for the first example, it says in triangle FGH, X, Y, and Z are midpoints. So that's really important because then we know we can use our midsegment theorem. What is the length of FG, XY, and YZ? So we're going to take this one at a time. So we're going to start with FG. So I'm just going to highlight FG. So we want the side that is parallel to that. So that's going to be XZ. Okay, so XZ is actually the midsegment. So we're going to say XZ equals 1/2 of FG. And we're just going to plug in what we know. We know that XZ is 19, so that equals 1/2 of FG. So we're going to multiply by 2 on both sides so that we get FG by itself. So 2 times 19, we're going to end up with 38 equals FG. Okay? All right, so for the next one, we're going to be looking at XY. So for XY, we're on this side, and we want the side that's parallel to that. So that's going to be GH. Okay, so for this one, we have XY is our midsegment, so that equals 1/2 of GH. For this one, we don't know anything about XY, but we do know that GH is 60, so we're going to go XY equals 1/2 of 60. Half of 60 is going to be 30, so XY equals 30. All right. So the next one that we have here is dealing with YZ. So for YZ, the side parallel to that is FH. So we have YZ would be our midsegment, sorry. YZ equals 1/2 of FH. For this one, we know that FH is 46, so YZ equals 1/2 of 46. So then we can say YZ equals 23. Okay? All right. So that's using our midsegment theorem. We're going to do one more example with that. This time we're going to be using some expressions. Okay, so again, we're going to be starting out looking at our midsegment. So that's this 7 with our other side. So we have our midsegment equals 1/2 of the side that it's parallel to. So that's our 3x minus 4. You can do this a couple different ways. One, you can distribute your 1/2 to each of those inside the parentheses. The other way to do that would be to multiply both sides by 2. That's actually what I'm going to do here. So then I get 14 equals the 3x minus 4. So then we're just going to continue to solve for x. We're going to add 4 to both sides. So we get 18 equals 3x. Dividing by 3, we get x equals 6. Okay. The next piece that we have for this one is dealing with y. So you'll notice here it says that those two pieces are congruent to each other. Congruent is another way of saying equals. So we're going to say 6y plus 3 equals 4y plus 11. And then we're just going to start moving things around so we can combine like terms. So I'm going to move my 4y, so subtracting it, and I'm going to move my 3, subtracting that as well. We end up with 2y equals 8. Divide by 2, we get y equals 4. Okay, so that is our triangle midsegment theorem. The next one that we have for today is the triangle proportionality theorem, or the side splitter. So this looks very similar to this one. The difference here, you'll notice on the midsegment, D and E were midpoints on those segments. For the side splitter, it's not a midpoint, or we don't know that it's a midpoint. It could be, but this is if you don't know that that's a midpoint. So then for this one, we still know that these sides are parallel. And since they're parallel, then we know that the pieces that are created are proportional to each other. And again, keep in mind, we're using this theorem when we don't know that the triangles are similar. So these two pieces would be proportional to each other. All right, so if DE is parallel to BC, then we would know that BD over DA equals CE over EA. Okay, so again, we're looking at the pieces. So BD over DA equals CE over EA. Okay. All right, so let's try a couple of examples with that one. So we're going to come over here to example 3. We're going to find the value of n and m. So we're going to be starting with n. So if we look here, we've got our pieces. So we're going to go 12 over 15 equals our other pieces, which would be 4 over n. Now keep in mind, this is not drawn to scale, okay? So don't let that throw you off. So then from here, you can either reduce this fraction to simplest form, or you can just go ahead and multiply, cross multiply from there. I'm just going to go ahead and cross multiply from here. So we get 12n equals 60, dividing by 12 on both sides. And we end up with n equals 5. Okay? Once I have n, then I can look at this triangle and decide whether the small triangle and the large triangle are going to be similar to each other. So in order to check that, remember we had our 3 theorems. In one of the earlier videos, we could either use angle, angle, side, 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 or side, angle, side. So for this one, I know that this angle is congruent to itself in both of those triangles. So I'm going to try to prove side, angle, side. Okay, so in order to do that, I need to have 4 over 9, because we said n was 5, so the whole side for the big triangle would be 9. The small one is going to be 4. That would need to equal 12 over, this whole big one is going to be 27. Okay, those do actually simplify down to be 4 over 9, so they are proportional. So I can use side angle side to say that these two triangles, the little one and the big one, are similar. Since they are similar, we can come back in and we can use our similarity, what we know about similar triangles, the proportionality, to be able to find m. Okay, so I'm still going to be looking at our corresponding parts. So now we're going to be working with our 4 over 9, which is our scale factor, equals m over 18. Okay, so then from there, we're going to cross multiply. So we get 9m equals 72. Dividing by 9, we find that m equals 8. Again, so the way I got this was I used my scale factor equals the small side over the bigger triangle side. We have the small one over the bigger one. So that's why I had them set up in that way. Okay? All right, so let's keep going here. So the next one that we're going to do over here, example 4, it says find the value of x. So if we look at this one with our side splitter theorem, we can say that 12 over 4 equals x over w. Now I don't know about you, but I don't like to deal with two variables at the same time. So I'm actually going to look at this w and see if I can write w in terms of x. So if I was trying to find w, what would I do? I would take 20, which is my whole length, minus my x value. So 20 minus the x. So I'm going to substitute this in for my w. So I have 12 over 4 equals x over 20 minus x. So again, now that I have my proportion, I'm going to cross multiply. So I end up with 4x equals 240 minus 12x. Again, you could have simplified here if you wanted to, but you don't necessarily have to. All right, so then from here, adding 12x to both sides, we get 16x equals 240. Dividing by 16, we end up with x equals 15. If you wanted to solve for w, we would then plug that back in. 20 minus 15, w equals 5. Okay. All right, so the last theorem that we have, I'm going to go ahead and shift this up just a little bit so it's easier to read, is our triangle bisector theorem. So remember what a bisector is. Bisector means that we're cutting the angle into two equal parts. So that means this piece is congruent to that piece. So if we have an angled bisector, it says if a ray bisects an angle of a triangle, then it divides the opposite side into segments. So that's AD and DC, whose lengths are proportional to the lengths of the other two sides. Okay, so the way that looks is we're going to say AD over DC. So those are our two pieces, equals BA over BC. So that's the two sides. Okay, so the two pieces that are created are proportional to the two sides. And again, the way I set this up, AD is adjacent to BA. DC is adjacent to BC. So let's go ahead and go over here to example 5. We're going to find the value for y. So we're going to start with our two pieces here. I've got y over 5 equals, the piece adjacent to y is 12, the piece adjacent to the 5 is 10. So then from here, we're going to cross multiply. We get 10y equals 60. So y equals 6. Okay. All right, let's move on to the next one, example 6. So for this one, it says YW bisects angle XYZ. So angle XYZ, these two pieces are congruent. So they want us to find N. So again, we're going to look at the side that's being cut, and we're going to say N over 15 equals the piece adjacent, or the side adjacent to N is 10. The side adjacent to the 15 is 20. And then we're going to cross multiply. You could also simplify this fraction again if you wanted to, but I'm just going to leave it the way it is and solve that way. So 15 times the 10 is 150 equals 20n. Dividing by 20, we get n equals 7.5. Okay, that is all that I have for you today. Have a great day. I'll see you in class.